Make your own steps. Solve these equations for x. Now, there are many, many, many different ways to solve each equation. It's going to be up to you to decide how you want to solve these. I'm going to show you some efficient ways. I'm going to try to talk you through some options that you have. But one thing to remember, so we're going to make some notes here. Notes, simplify first. One side at a time. Just like all of those problems that we just did with Claire and Lynn, Mai and Noah, they're all simplifying everything first. Usually that's where you want to start. Okay. Not always, but that's what you want to look at first. Sometimes simplifying isn't going to be the most efficient process, but you should look at doing that first. The second thing is whatever operation you do to one side, you've got to do to the other. Keep the hanger balanced. What happens on one side has to happen on the other. If you add 3 to one side, you have to add 3 to the other side. If you add negative 10x to one side, you have to add negative 10x to the other. So once you start truly changing things mathematically, you have to keep the hanger balanced. All right, so let's look at number 1. Now, the are you ready for more? You can scribble that out, or you can do that on your own another time, but we're actually going to use the space underneath for 4.3. So number 1. So recopy number 1 down. There is a lot going on here. Okay. And there are a lot of different ways that you can approach this. And feel free at any point, if I go through and complete a step and you would have done something different, try what you would do. We should both come up with the same exact value for x. As long as we both did the math correct, you should get the same value of x that I did. So at any point in time, if something makes more sense to you, do it that way. As long as you're keeping everything balanced. So what I would do here is I would try to simplify things first. For example, 5 minus 9 is actually 4. So I would rewrite this, and it's negative 4. I would rewrite it like this. Well, I guess simplify is probably just better. I don't want to start saying subtract and then you're wondering why it's not happening on both sides. So now we still have the 3 and the 2 here. And I know fractions are things that, make a lot of students nervous because you don't get a ton of practice. But remember too that for the most part, we're not going to give you anything that's like out of control, especially at this point where we're still starting out and learning. So when you look at some of these, think and say, well, maybe there's a way to like deal with these fractions quickly and easily. So if you look here, the left side is just saying 12 plus 6x divided by 3. Everything up here is actually being divided by 3. 12 divided by 3 is 4. 6x divided by 3 is 2x. I can actually take this and simplify it. It's kind of like, the distributive property, the numbers being multiplied by everything inside. In this case, everything up here is being divided by 3. And then on the right-hand side, -4 divided by 2 is -2. And I just simplify it again. So I haven't done anything on both sides. I'm actually just taking the expression on the left and just trying to simplify it down to something that doesn't look crazy. And then I'm looking at the information on the right and simplifying down so it doesn't look crazy. Now I actually have something that doesn't look too bad. Now we haven't solved anything by ourselves yet. All we've done is look at what other people have done for steps and written out the things they did, identifying the steps that happened. So now that we're moving to doing this by yourself, you need to think in a way of our goal is to find what x equals. Okay, if we had a hanger, what would that hanger look like? Okay, so if we had a hanger, what would the hanger look like? So if I were to draw a hanger for this problem, so 4 plus 2x minus 2. So if I were to draw a hanger, 4 plus 2x equals -2. So if I were drawing a hanger of this, I'd have 4 positive pieces and 2 x's, right? Then on this side, I would have 2 negatives. And it's balanced. So how are we going to deal with what we have here? How are we going to find our x's? I need to figure out what these x's equal. And there are options. Okay, if you look at the hanger, one option, if you look, you can see I could break these into 2 groups. An x and 2 positives, an x and 2 positives, and break these into 2 groups. And so if I looked at it like this, I have an x plus 2 equals a -1. Maybe from there, you could kind of see what to do. And all that happened was I divided by everything on the left by 2, and I divided everything on the right by 2. So if I look back at my equation, do you see how I can divide everything on the left by 2, and I can divide the number on the right by 2? So maybe that's what you want to do with your equation. Okay. Another option, if you didn't want to divide by 2, so let's say we didn't want to do that. That feels complicated or whatever. I could look and say, okay, well, on my hanger, if I want to know my x's, I've got to get rid of these 4 positives. So to eliminate the 4 positives, I'm going to use 4 negatives. because a positive and a negative cancel each other out, right? So the reason I do that is because if I have 4 positives, if I take 4 positives away from the left, I don't have any positives to take away from the right. That's why when I've been talking about subtraction making things difficult, this is another example of that. If I take 4 positives from the left, I don't have any positives to take from the right. But if you think about it like this, a positive and a negative cancel, 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 cancel. So it's like putting them together, make them disintegrate almost. Well, if I put 4 negatives on the left, I've got to put 4 negatives on the right. Nothing is going to cancel because they're all negatives. So if you look and see what I have, I've got 2 x's over here. And I've got 1, 2, 3, 4, 5, 6 negatives. And what we did was we added 4 negatives to the left and 4 negatives to the right. So in my equation here, I could add -4 to the left and -4 to the right. So now what I want you to do is I want you to decide, what are you going to do? Are you going to divide everything on the left and the right by 2? Or are you going to add -4 to the left and add -4 to the right? So you decide what you're going to do. I'm going to show you both. So let's say the first part you want to divide by 2. So if everything is divided by 2, you're going to get 2 plus x equals -1. Oops, sorry. So now if we have 2 plus x equals -1, let's come back and we can do a hanger for this if you want to see, like if that hanger helps you. So if that hanger kind of helps, let me kind of get some paper here so we can see the hanger. So if you want to draw the hanger, I have 2 positives and 1 x. And on the other side, I've got a negative. So now the thing I did on the other hanger with the positives and the negatives are actually going to kind of come back here. So if I want to know about what this x is, I've got to eliminate the 2 positives. So I'm going to pair them up with negatives. Those disintegrate, which means I'm going to add, if I added 2 negatives to the left, I need to add 2 negatives to the right. Once I match these guys up, I'm left with x equals -3. So on my equation to the right here, I just write down what I did. -2 on each side. So I added -2. 2 plus -2 is 0, and all I'm left with is an x. -1 plus -2 is -3. Now, if this is the method you decided to use, that's good. I still want you to do the second option. If this is not the method that you wanted to choose, that's okay. We're going to do the other one, but I want you to copy this down anyway. I want you to have both so that you can see that either was an option in this case. Now, the dividing by 2, the only trick is if one of these numbers was odd, this might not have been the choice. And that's the thing about the choices. Sometimes the choices will be clear and it'll be obvious. Others is like this, where you actually truly do have different choices. Okay, so our other option, instead of dividing by 2 at this point, maybe you want to eliminate the 4, kind of like what I did with the blues. So eliminate 4 on the left and 4 on the right. Okay, so my other option again is what I did over here in the blue. So let me get rid of this. So I added 1, 2, 3, 4 negatives to the left and 4 negatives on the right. So when I have my equation, I added 4 negatives to the left and 4 negatives to the right. Add -4 to each side. 4 and -4 is 0, so I have 2x on the left. If you look on the right, I've got -2 and -4 makes -6. Now, if you want to look at this using the hanger situation, make a little room. So again, if you wanted to make this look like the hanger, I have 2 x's on the left and I have 6 negatives on the right. Well, I can't take an x off the left and an x off the right. That doesn't really make sense. It'd be silly to add things. But if you look here, I could actually group these up. I can break this up into 2 groups, and each group has x on one side and -3 on the other. So I could actually divide each side by 2. 2 divided by 2, -6 divided by 2. Right? So I could divide it up 2 on each side. And either way that I approach this, I get x equals -3. Now, this method on the right is the more traditional method that you probably learned in 7th grade or that a teacher would show you because it will consistently work every time. This left side method, dividing by 2 from the beginning, it works out really nice here, but dividing originally may not always work very easily every time. So keep that in mind. All right, now number 2. So copy number 2 down. X minus 4 equals 1/3 times the quantity 6x minus 54. So we've got to decide how we're going to handle this. Earlier I said try simplifying first. And that doesn't mean that you have to simplify first, but that's something you should consider from the beginning. There's nothing I can really do on the left, but on the right, we've been distributing in a lot of the examples we've seen. So think about distributing 1/3. Remember, multiplying by 1/3 is like dividing by 3. So 6 divides by 3 evenly. How about 54? Does 54 divide by 3 evenly? It does. Okay, 54 divided by 3 is 18. So distributing this 1/3 is actually a pretty good move to make for an equation like this. But think about what other options you have. What else could you do? Because eliminating that 1/3 is a really good idea. Could you have multiplied each side by 3? 3 times 1/3 is 1, so I could have multiplied each side by 3 also. If that sounds like something you'd want to do, go ahead and do it. See if you get the same answer as me. Just make sure that when you multiply the left side by 3, everything gets multiplied. But we're going to go ahead and we're going to distribute the 1/3. So 1/3 times 6x minus 1/3 times 54. Now you may be able to do this in your head, but I do want you to write it out like this because it's good to practice some fraction work. This is a negative 54, and it's actually going to stay that way because I still have this negative here. But if you remember how to work fractions, if you multiplied, you'd get 6x over 3. And that's going to simplify to 2x. 54 divided by 3 is 18. So we distributed here. Actually, we distributed right there. Now from here, if you go back and you take a look and see what some of the other problems, how they were handled when they kind of look like this, where we had x's on both sides, and we see like what people did, that might help you decide what you would do. So on the other side of your paper, if we take a look and see what Claire did, right here, Claire has an x and a number, an x and a constant, x and a constant. And she removed 4x from each side. So she eliminated one of the x's on one side. Okay. Lynn, here's this step here. Lynn eliminated the 3 from here, and she eliminated a 3 from this side. Okay. You actually have options. You've got to get rid of something, though. If there was something I could divide out of every part, I could do that, kind of like in number 1. But I don't really have that option. So what you're going to do is you're going to decide, do you want to get rid of the x on the left, the -4, the 2x, the -18? You can actually get rid of whichever part you want. You just have to make sure whatever you do to the left, you do to the right. So for example, if I wanted to eliminate the x over here, well, it's a positive x, so I would use a negative x on each side to eliminate that. If I wanted to eliminate the -4, I would add +4 to each side to eliminate that. Okay, if you think back to the hangers, let me get another piece of paper up here. If I were to draw this as a hanger, I have an x and I have 4 negatives, right? And on this side, I have 2 x's, and I'm not drawing 18, but I have 18 negatives over here. Let me redraw this as 4 negatives. So I have an x on each side, and I have 4 negatives here, and I have 18 negatives here. So if you were to try to balance this hanger, do you see how you have options? Right? I could remove an x from each side. I could take 4 of the negatives from here and 4 of the negatives from here. Now, if I tried to take these 2 x's, it would get weird because I don't have 2 over here. Mathematically, we can do it, but then the x's start becoming negative and it gets strange. So drawing a hanger actually is not a bad idea for some of these to kind of see how you would want to start working. So we're going to eliminate an x from each side. Okay, so we're going to take an x off of each side. Now remember, I can only combine x's with x's. Whatever I do to one side, I have to do to the other. This -4 stays. 2 x's become an 1x, and I have my -18 still. So if I look at my little hanger here, I removed an x from here and an x from here. So now I have -4 on the left and x plus -18 on the right. So now if you look over on this side, I have an x. So if I cross those out completely, I have an x here, but it's sitting here with 18 of these negatives. I need to get rid of those. I need to take out those 18 negatives. The only thing, it's hard to take away something that's already negative. So if I added 18 positives, 18 negatives, 18 positives cancel each other out. If I add 18 positives on the right, I've got to add 18 positives on the left. So these will cancel, and I just have x, and then I've got to do a little math for the left-hand side. So I'm going to write this on the equation. What I did on the hanger is going to happen on the equation. And I'm going to have to kind of go over to the right. So if I have -4 and +18, I actually end up with 14. -18, +18 cancel, and I'm left with x equals 14. So again, once we get to this point where we've simplified everything, once we've simplified, use a hanger. Use the hangers to see, like, what would you do? If you're not seeing the math jump out at you, use the hangers. Okay, and then let's finally look at number 3. Let me go back to red. All right, for number 3, so we have a negative sign outside, 3x minus 12 in the parentheses, then 9x minus 4 on the right. Now, this looks maybe like something you've seen before, probably not. But we have seen numbers out front. We saw a fraction in number 2. We've seen numbers all throughout our examples, but I don't see a number here. If you remember all the different things you've seen in math over the last few years, if you don't see a number in front of a variable or under another number, there's always a 1 kind of creeping around. That's happening here too. There's actually a 1 right here. This is actually -1. So even though it doesn't look like anything really is happening other than just a negative sign hanging out, that's actually a -1 that can be distributed inside here. -1 times 3x is -3x. Now remember, this is a -12. Subtracting 12 is the same as -12. -1 times -12 is +12. And we distributed -1. And if you look, what's kind of interesting is when you have a negative sign out in front of your, parenthesis operation here, look at what happened to the numbers inside. They actually became the opposite. Okay. So if we want to go back to the hanger scenario, let's draw a hanger of this. Except I'm not going to draw a bunch of pieces. we have negative 3x, and I have got 12 on one side, and I have 9x and negative 4 on the other. And we need to start eliminating things so that we have x's on one side of the hanger and the numbers are only on the other side. So think about, what do you want to eliminate first? If you wanted to eliminate the negative 3x's, I would have to add 3x's to each side. If I want to eliminate the 9x's, I need 9 negatives on each side. If I want to eliminate the 12, I need negative 12 on each side. So think about, which piece do you want to eliminate, and what are you going to do to eliminate it? Okay. I'm going to take this guy here, and if I add a chunk of positive 3x's, these are going to cancel, and these will combine. Remember, we only combine the things that are alike. So on my paper, I'm going to add 3x's to each side. And if I look back here, I've got no x's left here. I've just got 12, which is what I see here. On the right, 9 x's plus 3 more x's is 12 x's minus 4. So if I look at my hanger, this becomes 12 x's. And now I've got a constant. I have these numbers here that I need to get rid of. So if it's negative 4, I'm going to add positive 4 because that will kind of cancel. It'll eliminate from this side. That means I've got to, if I put that chunk on the right, I've got to put it on the left. So I'm going to add 4 to each side. Now I've got 16 equals 12 x's. So if I come back to my hanger, if I rewrite this, I've got 12 x's on the right, and I've got 16 on the left. Now, if we think about the other hangers that we did, at this point, I would have broken up into 12 groups. Because if I break this into 12 groups and I break this into 12 groups, I've done the same thing on both sides, right? Break this into 12, break this into 12. The only thing is that doesn't divide very evenly, but that's okay because all I have to do is say divide each side by 12. I can show that with a fraction. Simplify it, and I get 4/3. You could even stop there, unless, you're entering something online. The hangers will be helpful for you to start kind of getting some ideas of how to keep everything balanced and stay mathematically correct. And that's it.